Hi future doctors, welcome to the next class. In this class, we'll see Young's double slit experiment and interference. What is meant by interference and how Young's double slit experiment is going to be explained according to this interference pattern. Interference. So generally we will say don't interfere into my matters. Same like that. Interference means two waves are going to be superposed to each other. So those two waves should be coming from coherent sources. And what are the main definition? What is the main definition for interference? Means the variation of intensity of light. Already we discussed what is intensity, how it is going to be defined, and how the equation is coming. The variation of intensity or redistribution of light energy when two waves got superposed each other. So one source of light is going to be taken. So from source, light waves are going to be point source means so wavefronts are going to be spherical. So each and every source, each and every particle on this spherical wavefront will be acting as secondary source. That is only Huygens wave principle. So like this, it is going to be passing towards forward. So in this, whichever I am drawing thick line, that is going to be crest we will call. So whichever I am drawing dotted line, that is going to be trough we will call. So crest and trough. So crest and trough, it will be passing like this. Now, if it is going like this, no superposition will act place. Minimum two sources we require. Those two sources should be coherent, we will say. So what are coherent sources means? The sources which are going to give same color or same wavelength of light, same frequency, but constant phase difference. That is going to be S1, S2, two sources. Now, if you are observing from here, light will be coming like this. Crest, trough, crest, trough, crest, trough. Dotted line is going to be trough, thick line is going to be crest. Now see here, crest, trough, crest, trough. Now if you observe at one place, thick lines are going to be meeting. At one place, dotted lines are going to be meeting. So where thick lines are meeting, that is nothing but crest and crest is going to be meeting. Let us assume here. Where thick line and dotted line are meeting. So that is going to be, this is dotted line and dotted line. So that is going to be crest and trough are meeting. So crest and crest meeting means, so resultant amplitude, this is one wave, this is another wave. So crest and crest is meeting means you will be getting resultant like this. So here amplitude is going to be more. Therefore, intensity is directly proportional to amplitude square. Therefore, intensity is going to be more. So crest and trough, thick line and dotted line is meeting. So there, how it is, those are going to be meeting means crest and trough. Therefore, intensity is going to become 0. It will be coming like this. So where crest and crest is meeting on the screen, it will be visible like this. So this one we will call central bright band. Central bright band means here more intensity of light is going to be coming. It is bright. Next, you are going to get dark band. So dark band means their intensity is going to become 0. Crest and crest is going to be meeting. Next, again you will be getting bright band. Again you will be getting dark band. So this is going to be dark band. Again you are going to get bright band. So like this, bright and dark bands are going to be forming. This is called redistribution of energy. Here light energy is going to be more, here it is going to be less. This redistribution of light energy, when two light waves are superimposed each other, we are going to call it as interference pattern. Again bright band, so below one it should be dark band. So this is going to be dark band. Again another one, it is going to be bright band. So next one will be dark band. Like this, bright and dark bands will be forming. This one we will call central bright band. This is called first dark band. First dark band. This is also first dark band below the central bright band. This is called first bright band. First bright band. This is second bright band. So first you can use like this or second bright band. That is your wish, how we are going to take. So like this, it is going to be redistributing whenever crest and crest is meeting, intensity is going to be maximum. Whenever crest and trough are meeting, intensity is going to be minimum. So the distance between these two slits, we will call the distance between these two slits. So in some books they will write 2D, somewhere they will take D. So our wish that is. Next, the distance between these two slits and screen is going to be capital D they are going to take. And here source we are going to use single color light. That one only we will say monochromatic. So chromatic means color, single color light. So these two waves how we are going to take means y1 is equal to A sin omega t. So y2 is equal to A sin omega t plus phi. So both are having same amplitude, so same angular frequency or frequency, constant phase difference, single color light or monochromatic light, which is divided by two sources are going to be interfered. Interfered means superimposed means redistribution of light energy is going to be taken place like this. Therefore, we are going to get these bright and dark bands. So this redistribution of energy we are calling it as interference pattern. So already these whenever superposed each other, so y is equal to y1 plus y2. So these equations already we have given. So maximum intensity y maximum, I minimum, so a1 plus a2 whole square. So all those we have given. Now we have to see at what distance from central bright band. So dark band is going to be forming, bright band is going to be forming, and what is the fringe width definition? Fringe width definition means the distance between two successive either bright bands or dark bands. Successive means this is first dark band means you have to take second dark band, not this third dark band. You should not take like that. So successive means next and next, bright and bright, dark and dark like this. That is called fringe width. Those definitions and how we are going to impose those equations, we will see according to phase difference and path difference. Now we will see from S1 to S2, same pattern. This is S1, S2, two coherent sources. If you are taking individual sources, two candles, if you are taking separately, interference pattern will not happen. So two sources should be coherent. These are incoherent sources we are going to see. S1 and S2 separated by distance D. Screen is going to be placed at a distance capital D. So from this S1, one wave is going to be traveling. It is going to be meeting at point P. Through from S2, another wave is going to be coming. It is going to be meeting here. So if at that point, if crest and crest is meeting, you are going to get here bright band. If crest and trough is meeting, you are going to get dark band, correct? Now, so what is the distance from here? What will be coming? Central bright band. From central bright band, what is the distance means? If it is forming nth bright band, what is the condition for path difference and phase difference? That one only we have given already, constructive, destructive, maximum and minimum. So it is going to be theta, let us say. This angle is making theta. So from S1 to P, wave is traveling. We are not deriving another equation. S2 to P, wave is traveling. So according to our common sense, so which wave is going to reach first P? Which is starting from S1 or which is starting from S2 means, so we can say very easily, who is starting from S1, they will reach P first, then S2. So therefore, some path difference is going to be happening between S1 and S2. What is the path difference means? This one. This is the path difference. This path difference we are going to call it as delta x. So S1 to S2, what is the distance we gave? Small d. Now if it is theta, this one also is going to become theta. So this theta delta x is which side? Opposite side. So sin theta is equal to delta x by, this is going to be hypotenuse. So you should remember this equation. Entire equations will be coming, all equations will be coming from only this equation. Delta x is going to be d sin theta. What is this delta x? We are saying it as path difference. So how we said path difference means who is reaching first means S1 is reaching first. After reaching S1, S2 is going. So just if you observe these two, everyone can say who is reaching P first. This is the path difference. So what is the condition to get bright band at point P? Path difference should be equal to, in previous class we explained. So what is the path difference means? So you have to take n lambda. Otherwise, you have to take 2n lambda by 2. So n lambda or 2n lambda by 2. Both are going to be same. So if path difference is equal to n lambda, you are going to get bright band. So if this delta x d sin theta, this path difference is going to be equal to either 2n minus 1 lambda by 2 or 2n plus 1 lambda by 2. So which is easy to take means generally you have to take this one than this. Why it is advantage than this, I will explain. So now it is the condition for dark band. So odd number is going to give. If you multiply lambda by 2 with odd number, you will get dark band. If you multiply lambda by 2 with even number, you are going to get bright band. Okay. So why we have to take easily means to get to 2n minus 1 means if you are taking n0, n0, n1. So n1 means you will say first dark band. Correct? This 1 if you substitute here, 2 minus 1, you are going to get lambda by 2. If you substitute this n here, 2 plus 1, 3 lambda by 2. For this lambda by 2, for this 2n means 3 lambda by 2 you are going to get path difference. If you substitute 1 in this equation, lambda by 2. In this equation, 3 lambda by 2. So for n1 you should get same. So what we have to do means if you are taking n1 in this equation, n you can substitute directly. But in this equation, whenever plus is there, you have to take one value less. Then n1 means first dark band means we have to substitute n is 0 if you are using this plus equation. Therefore, try to use this equation only. If they are asking first dark band, directly we will substitute n value 1. If they are asking second dark band, let us assume n value 2 you can substitute. 2 into 2, 4. 4 minus 1, 3 lambda by 2. If n is equal to 2, 3 lambda by 2. But if you use this equation, n is equal to 2 means 2 2s are 4 plus 1, 5 lambda by 2. Differently you are getting. So always whenever they are asking second dark band or first dark band or any dark band, if you are using 2n plus 1, you have to reduce one value. So in that anxiety during examination time, we may not have the conscious for us. Therefore, we will use directly 2n minus 1 lambda by 2. So we have to reduce one value. If you want to use this equation, second dark band means we have to take n value 1. Third dark band means we have to take n value 2. But this equation means directly we can substitute. Therefore, try to use 2n minus 1 lambda by 2. Next. So what is the sin theta from the diagram? So whenever theta is small, sin theta is almost equal to tan theta we will write. So what is that? Tan theta or sin theta means opposite side by. For this theta, opposite side by. So yn by adjacent side. So in place of sin theta we can write yn by d. So path difference delta x d sin theta is going to be n lambda. So small d. What is sin theta? Yn by d equal to n lambda. Then yn is equal to n capital D lambda by small d. So yn is the distance of bright band from central bright band. So that is the formula. So which bright band? Nth bright band. Now if you are taking this path difference, delta x is equal to d sin theta is equal to 2n minus 1 lambda by 2 you can take. Now what is sin theta? Yn by d. So 2n minus 1 lambda by 2. Therefore, yn is equal to 2n minus 1 d lambda by 2d. So this is the yn is the dark band from where? So from central bright band. So you are going to get this equation so many times. Path difference is going to be equal to d sine theta. So this is the dark band distance from central bright band. This is the bright band distance from central bright band. Now we will see what is the second dark band distance. Second dark band distance. Then y2 is 2 into 2 minus 1 d lambda by 2d. Then you will get 2 2s are 4, 4 minus 1, 3d lambda by 2d. This is the second dark band distance. So if you are using 2n plus 1, second dark band distance if they are using, then you have to take 2 times of second dark band means you have to take n value 1. 2n plus 1, so d lambda by 2d. Again you will get same answer, 3d lambda by 2d. So you should not substitute 2 if you are using plus. You have to substitute 2 if you are using minus. Therefore, that is the advantage of taking 2n minus 1. Don't take 2n plus 1. So directly we can substitute easily. So this is about nth bright band and nth dark band distance from central bright band.